Hi class, it's Mrs. Kane. Welcome back from spring break. I know it was probably not the spring break you had imagined, but hopefully you were able to take a break from some schoolwork and spend some time with family. I know a lot of you are working, so I hope you're not working too hard and that you're staying safe and healthy. I have my little one Chloe with me, so she wants to say hi.
Hi, class.
Hi class. Say do your work.
Do your work.
Please.
Please.
Say my mommy's working hard on these videos. Please watch them. All right, so we haven't figured out what we're doing with assessments just yet, so we are gonna move on to Unit 7. Unit 7 is we're gonna be talking about rational expressions. And just a reminder, rational expressions are fractions. So you've got a numerator and a denominator. So before we talk about, today we're gonna talk about simplifying rational expressions. But before we do that, we're gonna just talk about simplifying fractions and the rules about how and when we can simplify. We're also gonna be reviewing factoring today because we're gonna be using a lot of factoring in this unit. All right, so the first, in the warm-up, the first set of problems, we're just asked to simplify a fraction. This is a skill that some of you have gotten a lot of practice on in ALEKS. So when you simplify a fraction, you're trying to find a common factor. So 15 and 20 are both divisible by 5. And so to simplify this fraction, we divide the top and the bottom by 5. So 15 divided by 5 is 3, and 20 divided by 5 is 4. And so this fraction simplifies to 3/4. Okay, 3/12. If you try to think of a common factor, the numerator and denominator are both divisible by 3. And so we divide by 3. 3 divided by 3 is 1, and then 12 divided by 3 is 4. Okay, and the most common mistake on a problem like that is students will say 3/12 equals 4. Okay, but think about a pizza. If you have a pizza with 12 slices and you eat 3 of them, you didn't eat 4 pizzas, you ate 1/4 of the pizza. So just kind of be mindful, if the smaller number is on top, then that fraction is not going to be a whole number. All right, so then the last one, 24 over 26. So notice those are both even numbers. Okay, and so we're going to divide the top and bottom by 2. Sometimes you have to divide twice, but 2 will do it because your denominator is 13, which is prime. And so that reduces to 12 over 13. Okay, so just some quick practice reducing fractions. Now, the next set of problems, we're going to talk about when we're allowed to cancel out common factors. So when you have fractions, as long as the factors are being multiplied, you can cross out a factor that appears on the top that also appears on the bottom. Okay, so to illustrate that, let's think about 12 divided by 12. Okay, we know that when we divide a number by itself, it always equals 1. If I have a pizza with 12 pieces and I have 12 people, each person gets 1 piece if it's divided evenly. Okay, so a number divided by itself is 1. So if we have something like 4 times x minus 1 over 8 times x minus 1, think of this as a common factor. You have an x minus 1 on top, you have an x minus 1 on bottom. They're both being multiplied. On the top, it's being multiplied by 4. On the bottom, it's being multiplied by 8. Okay, so as long as it's a common factor, part of a product, then you can cross them out. Okay, and so in this problem, we're left with 4 over 8, which are both divisible by 4. Okay, they're divisible by 2, but you want to go bigger. So 4 over 8 equals 1 over 2, or 1/2. So that common factor can be canceled out. Okay, so similarly in part C, 12 times 3x plus 1, 3 times 3x plus 1. So when you see that multiplication, okay, these are common factors, and so they can be crossed out. 3x plus 1 on top, 3x plus 1 on bottom. And so we're left with 12 divided by 3, which is 4. Okay? All right, so that's going to be part of the skill set that we're going to be using on today's problems. The other thing we need to review is how to factor quadratics. Okay, so there's 3 types of factoring problems that we talked about. Okay, the first one is a GCF problem. So if I ask you to factor 2x squared plus 8x, okay, you're going to start by finding the GCF, the greatest common factor. Okay, so 2 and 8 are both divisible by 2. And then you have x squared and x. So they both have 1x in common. And so we take out a 2x. You're going to undo the distributive property. Okay, so 2x times x is 2x squared, and 2x times 4 is 8x. And so your factored form is 2x times x plus 4. All right, now the next type of factoring problem is your box problem, your area model. Okay, most of you got pretty good at this during Unit 5. So we start by putting x squared in the first box, positive 8 in the last box, and negative 6x up in the corner. Okay, so we need two numbers that multiply to give us positive 8 and add to give us negative 6. Okay, so if we use negative 4 and negative 2, you're going to tack an x onto those. Notice the diagonal, okay, adds to negative 6x. Okay, now once we think of those numbers, we take the GCF out of row 1. We can take an x out, and we're left with x minus 4. And then we're going to take a negative 2 out. And so we get x minus 2 times x minus 4. Okay, and then the last problem here, this is the other type of factoring problem that we focused on. I need you to recognize this as a difference of squares. Okay, you can also, if you wanted to think of the area model, two numbers that multiply to negative 9 and add to 0 are negative 3 and positive 3. Difference of squares, the square root of x squared is x, the square root of 9 is 3, so these are the ones where we do x plus 3 and x minus 3. Okay, so now we're going to take this skill set, the reducing and the factoring, we're going to put these together, and it's going to allow us to simplify rational expressions. Okay, so when we simplify rational expressions, we factor the numerator, factor the denominator, and then cross out any common factors. All right, so let's do a few of these together, and then I'll have you try some on your own. Okay, so the first set of problems we look at, we just have to factor using a GCF. Okay, so the numerator here, we're going to take out a 6, and we're left with x plus 1. And then on the bottom, the GCF is 3, so take out a 3. You're also left with x plus 1. Okay, and now you can find a common factor, cross out the x plus 1s, reduce what's left. 6 divided by 3 is 2, and so the answer is 2. Okay, so we don't see those common factors until we factor. The next one, you're going to go ahead and take a 2 out. This is a GCF factoring problem. Take a 2 out and you get x minus 3. Okay, 4x minus 12, we can take a 4 out and we get x minus 3. So once we factor out that GCF, now we see we've got a common factor. And then the last step is to simplify any remaining fractions. We know that 2 over 4 is equal to 1/2. Okay, so that's in general how we simplify rationals. Factor, factor, cancel, simplify. All right, let's bump it up a notch. So you'll notice in the last set here, we've got some quadratics that we have to factor. So if the numerator is just a linear expression, you don't have to factor it. So on this first problem, we only have to factor the denominator. So we need to factor the x squared minus 5x minus 14. So we need two numbers that multiply to negative 14 and add to negative 5. So we can use negative 7x and positive 2x. And that allows us to take out an x, and we get x minus 7, and then we can take out a 2. And so now we're going to replace the denominator with its factored form, x minus 7 and x plus 2. Okay, and our goal is to write everything in factored form so that we can see common factors. Now, one thing to be careful of here, we're going to cross out the x minus 7s. The leftover x plus 2 is in the denominator. So remember, when you cross out that x minus 7 over x minus 7, it's because it equals 1. And so if that leftover started in the denominator, it's got to stay in the denominator. And so the answer is 1 over x plus 2. Okay, so the next one, this time we have to factor the numerator. So we're going to go ahead and put the x squared minus 5x minus 6 in a box. We need two numbers that multiply to negative 6 and add to negative 5. So I'm going to use negative 6x and positive 1x. And then we can take out an x and we get x minus 6, and we can take out a 1. So this time on the top we have x minus 6 and x plus 1. And on the bottom, we have x plus 1. Okay, so when we cross out our common factors, x plus 1, this time the leftover is on the top. And so our answer is just x minus 6. All right, two more. so the next one, we need to factor the numerator and the denominator. I know some of you don't need these boxes, but during class as I walked around, I remember most of you do like to use the boxes. So do not feel obligated to use them if you know how to factor without. I just think they help a lot of students organize their information. All right, so for the numerator, two numbers that multiply to negative 30 and add to positive 1 are going to be positive 6x and negative 5x. So we can take out an x and we get x plus 6, and then we can take out a negative 5. So the top, the factors are x plus 6 and x minus 5. And then on the bottom, two numbers that multiply to negative 35 and add to positive 2. So we can use 7 and negative 5. So 7x and negative 5x, take out an x, and we get x plus 7 and x minus 5. So x plus 7 and x minus 5. So we're going to cross out the x minus 5s, and we're left with an x plus 6 on top and an x plus 7 on the bottom. Okay? And then the last one here, we're going to factor the numerator using a box. We need two numbers that multiply to 3 and add to 4, so we can use 3x and 1x, and then we take out an x and we get x plus 3, and then we just take out a 1. Okay, so on the top we get x plus 3 times x plus 1. Okay, notice the bottom is difference of squares. Okay, the square root of x squared is x, the square root of 9 is 3, so we do x plus 3, x minus 3. Okay, and then that allows us to cross out the x plus 3's. And so the answer is x plus 1 over x minus 3. All right, so I would like you to stop the video there and go ahead and try the last two problems. And then just fast forward to the end to check your answers. I'm going to just zip through these without any commentary because I want you to just check your answers. So I'm not even going to make the boxes on these ones. So x plus 7, x minus 5 over x minus 5. And then cross out the x minus 5's. And so the answer, once you check, should be x plus 7. And then this one on the top, it's going to be x plus 2 and x plus 5. And then on the bottom, take out a 4. That's a GCF problem, and you're left with x plus 2. And now you can cross out the x plus 2's. And so you get x plus 5 over 4. Okay, so the topic today was simplifying rationals. So the idea here, factor, factor, cancel, cancel, whatever you can, and then you reduce what's left. So I want you to go ahead and just try the 4 problems on the daily assignment and submit that via Schoology after you have checked your answers. Thanks for listening, and I hope to see you guys